Happy day students. Let's see the another topic here. Moment of inertia. So what is meant by moment of inertia? Generally what is meant by inertia? So inertia is nothing but, for example, let's consider an object of mass here. Now I applied a force on it. If it does not move, then what it has? Inertia. Okay. Now same object is in motion. It is keep on going. Now I try to apply force to stop it, but even though it's not stopping, some more it's moving, then that will be called as inertia. Okay, that means inertia is nothing but inability of an object inability of an object to its change its state means what? Either state of rest or motion or direction by its own. This is the important point. By its own, this will be called as inertia. The inability, it's not having any ability to change this state of rest or motion or direction by its own, by itself. Then we can call as inertia. So where it is happening? This is happening when an object is moving in a straight line. Okay, object is moving in straight line. But we are discussing about rotational motion only. No, in the rotational motion, same like translatory motion, we have one thing here that is only called as moment of inertia. Moment of inertia is there when an object is moving in an rotate. If an object rotates, then it has moment of inertia. What is meant by moment of inertia? It is defined as the sum of the products of masses of different particles supposed to be constituting the body and square of the perpendicular axis of rotation. So let's consider this is that object. Here what it have? This have different particles of masses, right? M1, M2, M3, M4. These are different types of particles. Let's suppose it is moving with, this is an axis of rotation from this point. This is the axis of rotation. With this it is going to rotate. So that means this particle is at a distance of r1, this particle is at a distance of r3, and this particle at a distance of r4, and this particle at a distance of r2. Okay, so between these two there is a distance between where from the axis of rotation to the mass. Okay, that is only called as moment of inertia. So these particles are moving from the axis of rotation at a point, right? So this will be called as moment of inertia. So this will be defined as simply I equal to mr square. Mathematically you can write like this, or you can define the same way. What here? Sum of the products of masses. This is for only one object. For another one, m1 r1 square, then I2 m2 r2 square, then I3 m3 r3 square. Like this you will have many. So if you add all these particles from the object, then inertia, moment of inertia will be sum of all the masses and square of the all the distances. So this will be called as moment of inertia. Okay, clear? Right. So let's see some points regarding this. That is, um, object is moving in circular path, right? Motion. So these have some velocity. What velocity? Linear velocity, and they are at distance, and they are with moving with the angular velocity v equal to r omega. When it is in a straight line, what is the kinetic energy? Half mv square. When it is in rotational motion, the kinetic energy will be half m. V is nothing but r omega. So it's r square omega square. So kinetic energy equal to half omega square. Here something is there, right? This is mr square. This is nothing but I. So I is called as moment of inertia, that is only called as mr square. So I equal to mr square. Okay, got it. So Simply you can say that it is the sum of, it is not only one, it is the sum of masses and square of the distance between them, that is called as moment of inertia. Okay, got it. So this is also called as, moment of inertia is also called as rotational inertia. Moment of inertia is also called as rotational inertia or rotational analog of inertia, anything it can be called. Okay, so a measure of rotational inertia is also called moment of inertia. Okay, measure of, generally measure of mass is inertia, mass is the measure of inertia. Okay, similar when it is moves in a straight line, but as it is moving in circular path, then it have rotational inertia, that is only called as rotational inertia is a measure of moment of inertia. Okay, clear. So let's see some points on it. Or so this moment of inertia I equal to mr square, right? So is it a scalar or vector? I equal to mr square. So it is not a scalar as well as it is not a vector. It is a tensor quantity. Okay, so moment of inertia is not a scalar, not a vector. It is a tensor quantity. Okay, right. Next, so what will be the, this is the formula for this. Then can you tell me what are the units for this? Mass is kg, distance is meter square. So moment of inertia units is kg meter square. Okay, right. Next, what is the dimensions for this? Kg m power 1, meter, meter means L power 2. Time is not there, so T power 0. So this is the dimensional formula for moment of inertia. Next, see, moment of inertia depends on what? Moment of inertia depends on mass and also its distance. That means mass m and distance r. Okay, from where? From the axis of rotation. If it is rotating from here, this particle has a distance and this is a distance of r, then it depends on both distance and mass. If the distance increases, then inertia also will be increases. Clear? Right. Next, it is independent of angular velocity. With what velocity it is moving? It is rotating. We don't want that. It does not depends on the angular velocity. And frequency, when it is making an oscillations, then it have frequency and it will take some time to rotate it. So that is time period of rotation. So moment of inertia is independent of angular velocity, frequency and time period of rotation of the body. Then it depends on what? It depends on temperature also. Mass as well as temperature as well as size and shape of the body also. Okay, size, shape of the body and as well as its axis. It increases with increase in temperature. If the temperature increases, temperature of the body increases about its axis, then moment of inertia also getting increases. Next, see the last point. If a body has large moment of inertia, for example, if an object is placed on a surface of mass m, if it has more mass, then there will be more inertia. Then here, if a body has large moment of inertia, it is difficult to start rotation. We cannot make it to rotate. If we have more inertia, we cannot make it to rotate, as well as while rotating we cannot stop it also. Okay, this is about simple moment of inertia. Okay, here I want to give one thing. Here one particle is there, I equal to mr square. Okay, done. Here there is one more particle. No, like this there are many particles are there. If you consider some object here, okay, object, or let's consider ring itself. In this there are many particles are there. Each particle mass is dm. Okay, each particle mass is dm. Total mass is m. Each particle is dm. Okay, right. All the particles are at a distance of r, right? So what is the formula for moment of inertia? I equal to summation m r square. So here I equal to, instead of sum we are about to integrate. Why we need to integrate? We are about to add all the dms, all the masses from the different distances. Okay, so I equal to r square dm. Here distance is same only, no, distance is not changing, right? Then what is changing? Mass is changing. Here one element, here one element. If you add all those things, then I equal to integral dm is nothing but m r square. So this is about integration. Okay, you should learn the integration. What is that integral? X power n dx equal to x power n plus 1 by n plus 1. If it is an integral dx, then that will be nothing but x. Okay, these two are important, and as it is very needy to solve these problems. Okay, I equal to mr square, moment of inertia, mass and square of the distance from the axis of rotation. That is important. From the axis of rotation, at what particle you are taking, that distance only r square. Okay, right. Next, radius of gyration. So it is the distance whose square when multiplied with the mass of the body. So radius of gyration going to denoted with k. Let's consider this is the axis of rotation. Here is the body. Okay, this body is making rotations with respect to this axis. Let's consider this total mass. Total mass, where this total mass will be concentrated at this point. That is the total mass. So this total mass from the axis of rotation at some distance, that is called as radius of gyration. Okay, so simply moment of inertia, what is the formula? I equal to m r square. Here I equal to m k square, where k is called as radius of gyration. Okay, so k square equal to I by m, then k equal to root over I by m. Okay, this is the radius of gyration. Can you tell me what are the units for this? So units for this is, what is the units for moment of inertia? Moment of inertia is kg meter square by m means what? Mass, kg gone. Then units is meter square. CGS units centimeter square. Okay, clear? Is it? Here square is also there, no? So root. So square and square gets cancelled. Then its units is meter or centimeter. So units for radius of gyration is meters or centimeters. Okay. Then what is the dimensional formula for this? M power 0, L power 1, T power 0. And this radius of gyration depends on this position of axis of rotation, at what distance it is. Okay, that is nothing but k, no? So it is the position. It depends on position of axis of rotation and distribution of mass, where it is distributed, either here or here. That means where the total mass is concentrated. Okay, total mass. Okay, clear? And as well as this will be increases same like a temperature. When the temperature increases, then this radius of gyration also will be increases, as well as it does not depends on angular velocity, frequency and time period. Okay, clear?